does infinity cause insurmountable problems in modern physics? Each speaker has 3 minutes and we'll go alphabetically. David Deutsch.
Well, there have been infinities in fundamental physics since antiquity, mostly harmless. I'm not actually sure which ones are most feared today, but never mind that for the moment. Suppose we were discussing zero instead, like medieval sages who didn't have Zoom, but might have gathered in their cloisters, gravely debating the propriety of zero and deciding, no, it's improper, because zero, by definition, can't refer to anything in the real world. It's nothing. No one can imagine nothing. It's incomprehensible. To dare to apply it to nature is sheer hubris. Nature abhors a vacuum. We may laugh at that, but this archaic fear of zero is inseparable from the fear of infinity. Take Zeno's paradox. To walk across the room, you first have to get halfway, and before that, a quarter way, and so on. So to move at all, you have to perform an infinite number of actions, physical actions. Zeno was wrong because a philosophy of mathematics can't determine whether walking across a room makes sense or not. If a good scientific explanation says it does, then it does. And classical kinematics does indeed explain that a vacuum, empty space, is not the same as nothing. Nothing wouldn't have a geometry, for instance. Today, both of our two deepest theories, relativity and quantum theory, give empty space much more structure than that. And again, that very structure leads to various infinities, infinite physical quantities. But this time, neither theory says that you can walk right across the infinity. So what's lacking in these theories is not that they invoke infinity, it's that they invoke something they don't explain, what these infinite things do. And that's a problem, but not a crisis. There are always problems at the cutting edge of physics because a deeper explanation always reveals a still deeper problem. If that were ever not so, then there would be a crisis.